Hello, today we will be learning how to use sap2000 to create your structural models for your structural analysis of your buildings. So first you want to do is to create a model in sap2000, but before you do that, let's just check first if the units is right. So here in the Philippines, we typically use kilonewtons, meters, and Celsius as the main units. So like that, and then next you have to do is to click on new model or control N. So this window shows, and you have different templates to choose from. There is the blank, grid only, beam, 2D trusses, 3D trusses, 2D frames, 3D frames, wall, flat slab, shells, staircases, storage structures, underground concrete, solid models, pipes, and plates. So in generating a model for your building, my recommended template is the grid only template because it's easy to manipulate, and we'll show you how to do that. So when you click on the grid only template, this window shows. So you have different values to input here, the number of grid lines, the grid spacing. So if you already have your floor plan, you could just edit these values and have your grid. But what I do is I just press OK and then edit later so that I can see what my grid looks like. So press OK, and then it generates your model in a 2D plane and then a 3D plane, 3D view. So if this is not what your floor plan looks like, you can just double click on any grid point anywhere to edit the grid. So here we have this new window. So you see we have two options here, the ordinates or the spacing. So since we're making a model for our building, and basically most certainly we have our floor plans already, so the easiest or the easier option is to use spacing. So basically it asks for the spacing of each grid line. So here in the X grid, if for example I want this line to be 4 meters only, this wall, I'll just input 4 here, this one, and then it changes there, so I can see the progress that I'm making. And then this one I want to make it 4 also, and then let's just leave the last one as 6. So that's it for the spacing. And for the the Y grid, you can also edit it if you want, and I want to make it uniform at 6 meters, just for an example. And for example, you only have 3 floors or 2-story building with deck, or a 3-story building. This one shows here that you have 5 floors. So you could just, or 4 floors, you could just delete this one, the last one, and then you only have 3 floors. So this one is from the footing to the first floor. So say we have a 1 meter footing. So just say 1, put 1. And then this is 1 meter from the footing to your ground floor. Then from your ground floor to your second floor, this is 3 meters. That's a typical column height. And then from your second floor to your rooflet or to your third floor, you have also 3 meters. And then from your third floor, that's the last floor, you have 0. So if you opt to use the ordinates option, it's basically the same, but the 0 ordinate is here in 1A or A1. So if you want to change the distance of this grid, you just input the distance of that grid from the 0 ordinate. So It's easy. So this grid is the distance from the zero ordinate is from the origin is 8. So that's why the value there is 8. And that's why I said I like spacing more, because it's what is shown in your floor plan. And so it's easy to input. So you just have to click OK. And then your model is changed. So as you notice here, your 2D model is not shown. So because it is indicated here that the Z is at 12, and since we changed our Z earlier, it only has 1, 2, 3, 3, I think 10. So there's no Z is equal to 12. It's here, up here, right? It's highlighted. So what you want to do is to transfer that Z to here, to the bottom part. So we just click here, the set XY view, and then you have your 2D plane, XY plane, and then so this is just your grid, not yet your structural model. This is just a guide. So next thing you want to do is to define first your materials, that the materials that you are gonna use. So of course the common, I just go here, define, and then go to the material section and click on it. You can see that the materials, the default materials here are 4000 psi and A992 FY50. So it's, I think that for the steel, but this one is for concrete. So let's add a material for concrete, and we'll use the 3000 psi concrete, which is the type A, the plus A mix. So 3000 psi. And then we'll also add for our steel, or for our rebars. Let's add grade 40 and grade 60. We don't know yet what we're going to use, but at least we already have our materials here ready. So the next thing you want to do is to create groups. Cut. So again, after you define your materials, I like to define the groups that we're going to make, so that it be easier for you to change the specifications later, just to be a bit more organized. So you go to the assign tab, and then go down to assign to group, and you see here that we don't have our groups yet, so you have to define our groups and then add new group. So we're gonna name this beams, then that's the color for it, and then we're gonna make another one which is for columns. Okay, and then we close it. So after that, we're gonna input, or we will now put or draw our columns and our beams. So here in our 2D plane, we are looking at the XY axis, and it is at Z is equal to 0. So we're gonna have to move up. Yeah, we're going to move up to Z is equal to, this is 1, 4. Z is equal to 4. Okay, so here we go to view, then set 2D view, and then as you can see here, it's z is equal to 0. I just put 4, and then apply. And now we're at z is equal to 4. So we'll first put our beams there. Okay, so now we will draw our beams. It's as easy as that. Just click on it. I specifically stops. So, and then, so after putting this lines for your beams, you can just click, and this is just a shortcut. Instead of putting it one by one, you can just click on it and then press Ctrl R to replicate. So um, since you want to replicate it uh, here and here and here, and that distance is 6, and the ordinate is this one is the origin, and then the positive is going up and the negative is going down. So you're gonna put -6, and then 3 times because you want it to be replicated 3 times. 2, 3. So click on apply. Then you already have it done. And now you want it to be, I want that, I could just do that next time. So we'll copy it when we're done. So we'll continue with this side. One, and then last one. We'll do the same. Click on this select mode and select so things you want to replicate. And then we want to replicate it going here. So on the x direction now. So this one would be 0, and then on the x direction you want it to move 4 meters, but only twice because this one is 6. There, and then you click OK. And this one, good, copy it. 6. Sorry. And then it's done. So you're done with the first floor, second floor. To copy it to the next floor, you can just select all of it and then replicate. The power of replicate. So now we're going to replicate in the z direction. So the distance is 3 meters. So I'm gonna put 3 and then it's just 1. And then we have it done. Easy peasy. Now we're going to do the columns. Oh, before all of that, just select this first and all of it. Just select all of it. And then let's assign it to a group. To beams. Oh, so when I click on this, no, this one. Well, it's not indicated here, but let's continue on putting the columns. So let's look at now we're done with the XY plane. To put the columns, we'll go to the XZ plane. This is XZ, or the YZ. Anything you want. Which one do you prefer? I'd like the XZ. So, because we can just replicate it to the Y direction, and they have the same distances. So, let's put lines there, there, and then to the footing. Let's do replicate. Control R, and then replicate it to the X direction, X direction at 4, and then 2 times. Done. And then let's just draw on this one. So you're done with the columns for this side. And let's just select on it and then assign it to a group, the columns. There you have it. And then let's just replicate this. Okay, now all we have to do is to replicate the columns to all the other sides. So since we already grouped it to columns, we can also do this one check. So press on select and then select, then go to groups, or you have this control G. So you could click on this group, the columns, and then press select. So it's selected already. So you don't have to click one by one. And then control R to replicate. And then let's replicate it in the Y direction. 0, Y. Distance is -6. And it's gonna be copied 1, 2, 3 times. Now we have our columns. Oh, we forgot one thing. Next we have to do is to assign our supports or our restraints. So you go to assign, then the joint tab, then you go to restraints. So in making a building, the footing is usually a pinned connection. Well, if you look at it, it looks like a fixed connection, but it's technically pinned because that's how you just do it in the construction. And you can, when you pour concrete on a footing, it's technically a pinned connection. That's why we will use this pinned option or joint in this structural model. So click on OK, and then you have to put it there, and there, and there, there. There, done. Oh wait, no. You shouldn't click OK. So put the joints there. Oh, wait, I'm messing this up. And you click apply. There, and then close. So you have your restraints, the pinned connection, and then we need to copy it or replicate it to the other columns. So we just select on that. No, let's unselect that. Sorry, because we included the columns accidentally. Click on it too. So let's try if this is possible to replicate it. So it's not possible. So let's just put the joints one by one. Sign joint again, and then this one. So let's put it there. It's pretty easy to do unless you mess it up. Or maybe, I just hope I didn't mess it up. So let's click on apply. It's good. And then create a close it. So let's see. So this, the keyboard shortcut for this is to press shift and then the mouse wheel so that you could orbit your model. And to pan is, the shortcut is the mouse wheel. Just click on the mouse wheel. So it's that. Dog Kalaman. Oh, sorry. Let's just redo that. It's a lag. So we've basically made our structural model already in sap2000. Next we have to do is to assign our load patterns. To define load patterns, first let's do load cases. So click on this define tab and then go to load cases. See here we have to add a new load case, and then wait, before we do the load case, I forgot, we first have to do the load combination. Load patterns. So the first one is of course the dead load, and it's named dead, and type is dead load, and the sub-weight multiplier here is 1. It means that the sub-weight of the structure is added or put in the dead load. So next we're gonna have to add another load, which is the live load. And let's just name it live, and live load A. Then the sub-weight multiplier is 0 because we already put it in. So let's add new load pattern, and then next is live load B. Next is we're gonna add the earthquake load. Just put EQ and then hit 0. And here, in using our standards that we follow here in the Philippines, we will just use the UBC 97 autolateral load pattern. So we have other standards here, the IBC for the Indian, and some other standards for the IS, but we follow the UBC 97. So add, and then if you want, you could also add the wind load. The snow, we don't have snow here, so let's just neglect the wind load for now. So okay, so for the load combinations, we'll add the load combinations now after defining the load patterns. So we will just use one load combination from NSCP 2010 to 15. I forgot. But let's just use one, okay, for the sake of an example. So for the dead load, the scale factor is 1.42, and then the earthquake load will do 1.25, and then that's the live load. Earthquake is 1.25, and then for live load, so for live load, we will put 0.5 scale factor, add, and then click OK. So basically, if you have other combinations, which is most likely the case for actual work, but just for uh, this example, we just use one. So in the real scenario, you most likely have to add a load envelope because there's most likely 4 or 6 or more load combinations. So let's just put one. Okay, and then that's combination 1. So we've now set our load patterns and load combinations. Okay, so after assigning the load patterns and load combinations, next thing that you will do is to assign the loads to your beams. So to do that, you just have to right click on your beam, then this will show. Then you have the loads tab, then you have to just to assign loads, then choose whichever load is applicable, so distributed, and then just have to put, for example, 10. Okay, and that's it. And you have to assign another one for the live load. Just have to add a live. Okay, and live. That's that. So that's it. Next is I will open a different or another file to show what happens after you have put or assigned every load that you need. So let's open. This is a previous project that I've worked on. So here I've already assigned the loads to each of these beams. So if you right click on it, look at loads, it already has the loads that is needed. So look at it, there are loads. So after that, you just have to now that you have the loads applied to your structure, next thing that you need to do is just to run analysis. So or run analysis or F5, and then run now. Here it shows the axial force diagram of the structure. So if you right click on this, it will show the values, and you could also scroll for values, the location. You could put the location here, and then you'll get the values. So also here, show max. So that's it. And you can change this display here, or the shortcut F8, to show the other diagrams. So for example, you want to see the shear diagram, here for the dead load, or if you want the live load A or the earthquake load or the dead load combination, the load pattern, the load combination, dead load plus live load, or this one. So this is what I talked about, what I said. In actual projects, you have lots of load patterns or load combinations, and then the load envelope. So this is just an example of it. So you could click on that and then show the shear diagram and click OK, and you will see. And also you could change the display to show the values for it. So just that F8, and you could click on this show values. So it goes like that. So again, after you've run analysis, you can look at your shear and moment diagrams. Okay, so before you run analysis of your structure, of course, I forgot to mention that you first have to define your frame sections, your RC, your reinforced concrete, or your steel. And for this case, it's reinforced concrete. So first is we define our frame sections. We've already defined our materials before, so we go now to frame sections. So for this project, this is a previously dot project, and I've already defined my frame. So I'm just gonna show you what it looks like. So for example, let's just neglect that these are not yet here. So for example, that you add a new property. Let's just add a new property. So it shows here a different types of section that you can have. This is for steel, the flange, channels, I-beams, and then there's concrete. So the steel is that it does not mean the rebars. It means a pure steel beam, or excuse me, for steel section. So we're gonna use concrete, and it's gonna be a rectangular beam. So here it is. You can change the display colors and the material. We've already set this material before, 3000 psi. And then here you can change the size. You say if I want it to be 0.4 and the width is just 0.2. So it looks like that, and then that doesn't really look good, right? So we could just change the reinforcements. The grade here is grade 40, and that's just right. And then we'll use the number of longitudinal bars along 3 directions. So 3 directions. You just put 2, and then here, of course, you just put 2. And here you could pick the size. So it's number 9, number 10, and if you're not sure with what diameter these numbers are, you could look here. So number 9 is, it's 28 or 29. Yeah, it's basically here. It's okay. So okay, it looks like that. Let's just cancel. So I already have my frame sections here. Click on OK, and then after you've defined your frame sections, for example, click on this section, and then you go to assign. You assign it to a section, frame, then frame sections. So you just click here, beam 1 or beam 2. For this case, it's beam 1. So it's already assigned to that. It's okay. So after you've assigned your frame sections, that's the time you could just run analysis of your frame. So now what we'll do is to run analysis of your entire structure. So let's just F5 for analyze, then run analysis. What we're doing now is we have to check if the building is safe or the structure is safe, and the rebars and the beam size and column sizes that we have set is safe. So go to design, then config frame design, then you click on this start design or check of structure. So its shortcut is shift plus F6. So it will check. There. Now let's look at it in 3D. You see that this indicates that the building is perfectly safe. So here, this one is the most definitely the critical design, and then the green one and the blue one up to this one is very safe. So we like to design our building to be safe and economically just right. So you don't want it to be over designed. So that's it. You're done with checking your structure, and that's just the basics of sap2000. And of course, if you want to see the tables for your loads, the moments and the shear, you could just go to display, and then this one, or you could go Control T, show tables, and then you just click here what you want to look at or what you want to see. For example, this is very useful. The element output, frame output, then the table for element forces, frames, element stresses, stress forces. So you can select load patterns. You could select all of it, or you could just select one. And you can select load cases. You could select all of it also, or just for example, let's just select the load envelope, and then click on OK. So it will show you this window of tables if you want it. For example, this is the member number 10. So you could also member number 10, and then the output case load envelope, and then you'll just show the maximum and the minimum, the actual force, the shear 2 2 and shear 3 3, torsion, moment, and that's it, and element station. So, and if you want this table to be exported to Excel, just another tip that helped me is you can export all tables to Excel, and then it will create an Excel file for this table.